Alright, hello everyone. Let's go ahead and take a look at this next section, which is called rational functions. Now, of course, what we've been trying to do with calculus is taking a look at the first derivative and the second derivative, and looking at the signs of the first and second derivative, and determining what's happening to the graph of f of x without actually having to plot so many points. So what we're going to do is we're going to take a look at a special type of function, and this function is going to be a rational function. And the rational function, by definition, is going to be f of x is equal to the numerator function of x divided by the denominator function of x. And that's why we're calling it a rational function, because you have a ratio of two functions. So notice the one thing that we cannot have is we cannot have d of x being equal to 0, because of course you cannot divide by 0. And notice that n of x and d of x are both going to be polynomial functions. So what does that mean? Let's just take a look at a couple of examples. So A says f of x is equal to x over x plus 2. Notice that we have two polynomials. This is a first degree polynomial. This is also going to be a first degree polynomial. Notice that with f of x is equal to 4x over x squared minus 4x minus 5. Notice again that we have a polynomial divided by a polynomial. And in this case over here we have 3x squared minus 3x divided by x squared minus x minus 6, and that's also going to be another polynomial divided by a polynomial. So what we're going to do then is, based upon these types of rational functions, let's go ahead and see what extra type of what other kinds of information that we can actually find, and also use that to help us determine what the graph will look like. So in addition to all the things with the first and second derivatives, we're also going to be using these pieces of information specifically when we're dealing with rational functions, because it will further help us determine what the graph looks like. So let's go ahead and start by taking a look at what other pieces of information we'll actually be able to find. So here you go. This is what, again, our objective is to graph the function. If we have a rational function, these are the extra things that we can find because of the fact that it's a rational function. First of all, the x-intercepts. Whenever we want to find the x-intercepts, we always want to make sure that we're setting the numerator function to be equal to 0 and solving for that value. That will be the x-intercept. Now we also want to know where our vertical asymptotes are, because our vertical asymptotes are lines, visually and graphically, are dotted lines, vertical dotted lines that our graph cannot cross. So that's going to help us also determine what the graph is going to look like. That's going to be important information. And the way that we find where the vertical asymptotes are is we let the denominator function be equal to 0 and we solve for that. Lastly, we're going to take a look at what are called horizontal asymptotes. Now, horizontal asymptotes are going to be what the graph is actually approaching as x goes to infinity. So what we're going to say then is that if we take the limit as x approaches infinity of n of x over d of x, then we can actually go ahead and find out what the horizontal asymptotes are as well. So let's go ahead and take a look at the examples, and let's just go through these three things here to make sure that we can actually find all the things that we're looking for with regards to the graph. Now, let's go ahead and just draw all of our x-intercepts with blue dots. Okay, now we're going to go ahead and let n of x be equal to 0. So in other words, we're just taking a look at the numerator. When is this numerator going to be equal to 0? Well, x is going to be equal to 0 when x is equal to 0. So in other words, you're going to have an x-intercept through there. Let's move on to the next one here. We said that f of x is going to be equal to 4x over x squared. And if we go ahead and just focus on the numerator is actually going to have x-intercepts again when x is going to be equal to 0. Now for c, notice that it's a little bit more complicated. In the numerator, we have 3x squared minus 3x. If I went ahead and factored this, then I set this equal to 0, and notice what I come up with 0 and x is with x being equal to 0 and with x being equal to 1. So I know that the function has to go through that point, and I know that the function also has to go through that point. So that's important information, because now we have more points that we know the function has to go through. Let's go ahead and also take a look at our vertical asymptotes. Now, our vertical asymptotes, of course, are vertical dotted lines that our graph cannot cross. We say that if we go ahead and let the denominator be equal to 0, that is where the asymptotes are. So, for example, if I go ahead and just take a look at the denominator here, that's x plus 2. When is that going to be equal to 0? Well, that's going to be equal to 0 when x is equal to negative 2. So when x is equal to negative 2, my function does not have any value when x is equal to negative 2. Therefore, I can draw a vertical asymptote using a dotted line, and my graph cannot cross that. The graph of the function cannot cross that line. Okay, so let's move on. Let's take a look at this other one here. We got x squared minus 4x minus 5. Again, we're trying to look for where the denominator is equal to 0. In order to do that, we need to factor, and we can factor this to x minus 5, x plus 1. So that means then if I let the denominator be equal to 0, x is going to be equal to 5, which is right here. So I know that I have a vertical asymptote here. And I have a vertical asymptote at x is equal to negative 1. Okay, so that's very important information that's going to further help me determine what this graph looks like. Okay, and with C, I can go ahead and again take a look at just the denominator. Notice I factored it again. And now I know that there is going to be a vertical asymptote at x is equal to 3, which is right here. And when x is equal to negative 2, which is right here. Okay.